Okay guys, welcome to a video on how to graph circular functions. I use a method which I made up. I call it chunk style, using chunks. Um, if you don't know what it is, I guess you're about to find out. So this is a little joke I have with my class. I say it's trademark to Worm, my nickname. Okay, so where does the first graph sine come from? So what I'm going to do first is get you to think about this. Here is a sine graph. I know certain values of sine. We've done that using the unit circle. Hopefully you would have learnt the unit circle before. If you don't recall, sine of an angle, theta, is the corresponding y value for that angle. So if I said to you, what's sine of 30 degrees? I'm going to make this a little bit smaller. If I said what's sine of 30 degrees, you'd go around to 30 degrees, read the value off the y-axis. That's sine of 30 degrees. If I said to you what's sine of 0 degrees, you go 0 degrees, read the value off the y-axis, and it's 0. Now, what I wanted to do is draw a parallel between the unit circle and the actual graph itself. We know that sine of 0 degrees is actually 0. So sine of 0 starts at 0 on our graph. We know that sine of 45 degrees, using our special triangles, 1, 1, root 2, pi on 4, it is 1 on root 2, which is approximately 0.707. So here, if I go to pi on 4, 0.707 is a value here. It's above a half. If we then said, so we've gone from there up to there, you can see between those two graphs, that's the same distance. If I go from there up to there, I get up to sine of pi on 2, which we know is 1, because it's the y value on the axis. It's the y value on the y-axis. Okay, so here, in this section here, we go from pi on 4 up until pi on 2, and that's where this part here gives us this part here. So from 0 to 1 is exactly the same as going from 0 to 1. Now, as we go down the circle, so we start at 1, which is 1 up here. Sine, if we're reading the value off the y-axis, it's going from 1, it's getting smaller, 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 until it goes back to 0. So it goes from 1, getting smaller, 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 back to 0. We know that sine of 3 pi on 4, which is that value there, we know that that's also 1 on root 2, or 0.707. So that's how we get our first half of a sine graph. Sine then, if we start reading it off the y-axis, it's negative, a really small negative number, then it starts going up to negative 1. So it goes down until it gets to negative 1. And then it goes from negative 1 back to 0, which is this here. So we're going back from negative 1 back to 0. So that's why a sine graph looks like that. It's basically going around a circle, and for every point here, every y value, we're just plotting that y value with respect to whatever our x value is, and we get a sine graph. Now, I said before something about a chunk, and everyone's probably wondering, like, what are you talking about with a chunk? Every graph, sine or cos, I split it up into 4 regions. This one here, the first quadrant, that's a chunk. The second quadrant, that's another chunk. The third quadrant, another chunk. And the fourth quadrant is another chunk. So whenever we go to graph a graph of sine or cos, this first section corresponds to this chunk. This second section corresponds to that chunk. The third section corresponds to the third quadrant, the third chunk, and the fourth section corresponds to the fourth quadrant or the fourth chunk. We know that it goes from, our values go from 0 to 1 and down to -1 because our y values go from 0 to 1 to 0 to -1 to 0. So that's how we get our basic sine graph. Now, it works exactly the same for a cos graph. However, cos, we read the values off the x-axis. So if I was to go around 30 degrees and read the value off the x-axis, cos of 30 might be, what is cos of 30? It's root 3 on 2. So root 3 on 2, that is about 1.7 divided by 2. What is it? 0.833? Let's have a look. Clear this. Root 3 on 2 as a decimal is 0.866. Okay, so it's 0.866. Okay, however, if we go around, like here, if I get the value off the x-axis, it is 1. That's why we start at 1 with the cos graph. As we go around the unit circle, as we get our x values, we slowly approach 0. So that's our first quadrant or our first chunk. And next chunk, we start at 0 and we slowly go to -1. So it goes down to -1. And then we start from -1. If we're reading the values off the x-axis, sorry, I just did it the wrong way. So if we're reading the values off the x-axis, -1, we're going back to 0. So -1 back to 0. And then we go from 0, read the values off the x-axis, we're slowly going back to 1. So that is why a cos graph looks like it does. It starts at 1, finishes at 1. Its period is 2 pi because it's a full circle, 2 pi, just like the same as with sine. So how long it takes to complete a graph is from 0 to 2 pi. Now, likewise, this has 4 chunks, chunk, 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 chunk. And you'll understand what I mean because it has 4 quadrants. You'll understand what I mean when we get a chunk, when we go into a graph. Okay, an amplitude is how far your graph goes up and down from the center. So the amplitude is a dilation from the x-axis. So it makes it either get, if the amplitude is greater than 1, gets further away from the x-axis. If it's between 0 and 1, then it will get closer to the x-axis, so it won't be as high. And if you think about it, this could be used for a sound curve. The louder you are, the higher the amplitude is. The softer you are, the lower the amplitude is. The period is the time it takes to complete one full graph. And it's actually a dilation from the y-axis. So if I had a graph that took 2 pi long, or if I had a graph that took pi long, this graph here has a period of pi, whereas this graph has a period of 2 pi. That's how long it takes to complete one cycle. And it's given by the period is 2 pi on n, where n is the coefficient. So n is the coefficient of your angle. Okay, so for f of x is a sine nx, the amplitude is a, so that's how far up and down we go, whatever the value of a is, and the period is 2 pi on n. For a cos nx, the amplitude is a, and the period is 2 pi on n, so that's how long it takes to draw one graph. Okay, so let's have a crack at graphing. So I've said here, whenever you graph a trig function, the first thing you should always do is state the amplitude, state the period, and then determine a chunk. And the way that you determine a chunk is by dividing the period by 4. Now it'll start to make more sense as we have a crack. So let's have a look here. Sketch f of x is 2 sine x for x as an element of 0 to 2 pi. So you want to graph from 0 to 2 pi. What I'm going to do first is say my a value is my amplitude, which we know is 2. So our graph has to go up to 2 and down to negative 2. My period is 2 pi on n. N in this case is just 1, so my period's just 2 pi. Now we know a chunk is the period on 4. So in this case it's 2 pi on 4, which is pi on 2. Okay, so we've got to graph this graph from 0 to 2 pi. We know it's got to go up to 2 and down to negative 2. So when we go to sketch our graph, the first thing we do, there's our maximum value, there's our minimum value. We know that our period's 2 pi, so it takes 2 pi to draw our graph. The halfway mark is at pi. We've got to cut it up into pi on 2, because that's our chunk. So pi on 2, and then this will be 1 pi on 2, 2 pi on 2, 3 pi on 2, 4 pi on 2, which is, of course, 2 pi. Okay, from here, we just go, it's a sine graph. Oops, can't spell very well. Sine graph. So, starts in the middle. So, let's have a look. Blue. Okay, it starts in the middle, so it starts at 0. Now, our chunk, we know, is pi on 2. So, every pi on 2 is a quarter of a circle. So, we know it's going to go to its maximum because it's a sine graph. It's then going to have another chunk which goes to pi. So, it's going to come down. So, that's the first quadrant. That's the second. This part here is your, oops, that's a bad graph. So, we know we're going to go down to negative 2, then up to 0. So we know that is the third quadrant. That's the fourth quadrant. We know that this point here is our maximum, which is pi on 2, 2. And then this point down here is our minimum, which is 3 pi on 2 and negative 2. Our endpoints are 2 pi 0 and 0, 0. Our range is y as an element of negative 2, because that's my lowest value, up until my highest value, which is 2. Our domain was given to us in the question. That's from 0 to 2 pi. So there's our first sine graph. Has an amplitude of 2, a period of 2 pi, and that's it. Okay, so here we've got sketch negative 3 cos 2x. Now, we've got to state everything at the start. My amplitude, it's not negative 2, it's actually, it's not negative 3, it's actually 3. Amplitudes can't be negative, they're always positive. But the negative out the front, we should know what that is. Is reflection in the x-axis. So we know the graph will be turned upside down. So we've got our amplitude. So we know our max is 3. Our min is negative 3. Our period in this case is a little bit different. And this is where chunks help. So our period is 2 pi on 2, which is pi. So it takes us pi, a distance of pi, to draw one full graph, which means that a chunk is now pi on 4. Now how does that affect our graph? We know it's got to go up to 3, down to -3. Try and keep your scale good. We know our graph's got to go to 2 pi, so our halfway mark is about pi. And we know that a chunk is pi on 4, so we've got to cut this up into 4, because it's pi on 4. Cut this into 4. Okay, so we know that's pi on 2. We know that each one of these notches, or the chunks, is pi on 4. Now, if we go to sketch it, what we need to do, it is a Cos graph, and it starts at the bottom because it's been reflected in the x-axis. So it starts down here. Every chunk is a quarter of a circle, so it's going to go here, up, up, down, down, up, up, down, down. Last point's probably not great. Okay, so from here, our graph goes up, and then down. Okay, so we've got 0, -3, pi on 2, 3, pi, -3, 3 pi on 2, 3. Our endpoint is 2 pi, -3. Our range is y as an element of, what's our lowest value? -3. And our maximum value is, lowest value is -3, maximum value is 3. Our period is pi. Because there's a 2 out the front, that means that we expect to do 2 full graphs, 2 full cycles between 0 and 2 pi. Because this, if you think about it, if I had a graph of f of x, and then I made it become f of 2x, that's a dilation of factor 1/2 from the y-axis. So it's actually, if you had a graph, a standard graph, if you halve all of your values, I dilated a half from the y-axis, that value would come in, that value would come in, that value would come in, so it'd all be halved, and then we'd have exactly the same graph again. So that's why if there's a 2 out the front, it doubles the number of graphs, and we end up with, between 0 and 2 pi, we end up with 2 full cycles. So that's -3 cos 2x for 0 to 2 pi. Okay, so that's just their basic graphs. We then have vertical translations, which move the graph, up and down. So it moves the graph, you can either move it up by putting a plus on the end or minus. It changes the maximum and minimum values. It's the average value or center of the graph. So we know when we graph a basic graph of sine, our center of our graph is at 0, or if we graph cos, our center of our graph is at 0. When we add something to the end, it moves the graph up or down. That becomes our new center. So here, if I had f of x is a sine x plus b, this b is our center. The amplitude is a, the period is 2 pi and n still. The center of the graph is b, so it's been moved up or down b. The maximum value, so if I move a graph up b, just say I moved it up to b, so it would go up to b. My maximum up here is b plus a, because the value of the amplitude, so it's the center plus the value of the amplitude to get your max. And the minimum is b minus a, because it's the center minus the amplitude to work out what the lowest value is. Exactly the same occurs for cos. So our maximum value is b plus a. The value, oh, I forgot to put a plus, there's supposed to be a plus b there. The amplitude is a, the period is 2 pi, and the center of the graph is b, because there's supposed to be a plus b there. The maximum value is b, our center, plus a, and the minimum value is b minus a. Okay, so now let's have a graph with vertical translations. Whenever you graph a trig equation, trig function, you should always state the following. So state the amplitude, the period. Now we're going to add in state the center. Determine the max and min. So it's the center plus the amp for the max. And then it's the center minus the amp. And that gives you your min. Then determine a chunk. Worm team method. Okay, so let's have a look here. Let's go green. We haven't done green before. Okay, so the first thing we needed to do was state the amplitude. Amplitude is 2. Period is 2 pi on n. In this case, n is 1, so it's 2 pi. My center is at 3 because it's been moved up 3. Therefore, if we add our amp, we're adding 2, which is 5. So that's our max. If we subtract our amp, we're subtracting 2 from 3. 3 take away 2 is 1, so that's our min. So we know our lowest value of the graph and we know our highest value of the graph. Makes it easier to graph it because we know what our y values are going to be between. They're going to be between 1 and 5. That's our range. Okay, next we said to determine a chunk. So a chunk is 2 pi. Remember, it's always divided by 4. So it's pi on 2. So when we graph our graph, we want to cut it up into pi on 2s. Okay, so we know we've got to go from 1 to 5. So let's say 1, 2, 3, 4, 5. We're now going to go to 2 pi. We know the halfway mark is pi. If we cut it in half, we get pi on 2. And if we cut this in half, we get 3 pi on 2. So we've got our chunks, like our distances for our chunks. We know that this graph is a sine graph. So it starts in the center. We know in this case our center is 3. So we start at 3. Now a sine graph we know goes up first. So after a chunk, pi on 2, we've got to go up to our maximum value, which is 5. Then after another chunk, we go down to the center, which is 3. After another chunk, we go down to 1. And after another chunk, we go up. So a graph looks like so there's our sine graph. So we've got 0, 3, pi on 2, 5. We know that this point here is pi 3. That's 3 pi on 2, 1, and 2 pi 3. Our range, we know y is an element. Our lowest value is 1, and our highest value is 5, of course, which comes from our max and min. So that helps you out determining what the range is. And the domain, of course, was given to us. Okay, so here we've got another graph. This is a Cos graph. Remember the negative out the front. That doesn't mean that the amplitude is negative. We just say our amp is 3. We say the graph is reflected in the x-axis. So instead of going like that, we know it's going to go like, oops, that's bad. We know it's going to go down like that. Okay, my period is 2 pi on 2. which is pi. So we're going to see two full graphs between 0 and 2 pi. My center is 2. We add the amp for our max, which is, if I say 2 plus my amplitude, which is 3, it's going to be 5. And if I say minus the amp for our min, so we'll say 2 minus 3, it's going to be minus 1. So we know the last thing we need is a chunk, which is our period on 4. So we've got to cut it up into pi on 4s, and it's going to be between 0 and 2 pi. We know our minimum is -1, our maximum is 5. So here, -1, 1, 2, 3, 4, just made it, 5. We've got to go up to 2 pi. We've got to cut it in half for pi. And then we know a chunk's pi on 4, so we've got to cut this up into 4, because there's pi, I've got to divide that by 4. Likewise here, we've got to divide this by 4. Okay, so it is a Cos graph, but it's upside down. So it's got to start at the bottom. So it's going to start at, instead of starting at 5, it's going to start down the bottom at -1. We know that every chunk, every chunk it's going to move. So my center is at 2, so it's going to go up to 2. Then at another chunk, it's going to go up to 5. Another chunk, it's going to go back down to 2. Another chunk, it's going to be at -1. Another chunk, it's going to be up at 2. Then it's going to be up at 5. Another chunk down to 2. And then lastly, it's going to be back down to -1. So now at the moment, we're not worrying about finding the axis intercepts, but eventually we will. Okay, so we know this point here, 0, -1. We know that this is pi on 2. So it's pi on 2, 5. This is pi -1. That's going to be 3 pi on 2. And 5. And then this is going to be 2 pi -1. Now, of course, our period was pi. That's how long it takes to complete one full graph. And we've got two full graphs here because it's between 0 and 2 pi. My range, y is an element. What's my lowest value? -1. What's my highest value? 5. Okay. Okay, sketching for different domains. So it's not really any harder if you have the following rules and draw the correct axis and chunks. So let's graph with vertical translations. And I should have said and different domains with an exciting exclamation mark. Okay, so whenever you graph it, state the amplitude, state the period, state the center, determine the max and min, determine a chunk, team worm, set up your axis with a given domain and the chunks. Okay, so here we know we're from -pi to 2 pi. Let's have a look first. What I'm going to do is write it down here because it's not far enough down. So fx is cos 2x minus 2, x is an element, -pi to 2 pi. Okay, so my amplitude is 1 because there's nothing out the front. My period is 2 pi on 2, which is pi. My center is at -2. So my max is -2 plus 1, which is -1. My min is at -2 minus 1, so that's negative 3. A chunk is my period on 4, so pi on 4. Okay, so we know our max is negative 1, our min is negative 3, our center is at negative 2, so we want to go negative 1, that would be 1, negative 2, negative 3. Our graph has to go from negative pi to 2 pi. So if that distance is pi, then if we go again, that's going to be pi. That's going to be 2 pi. If we remember, our chunk is pi on 4. So we've got to cut this up into pi on 4. So if I chop that in half and chop that in half, that's pi. They're all pi on 4s. Cut it in half. Cut it in half. Cut it in half again. Okay, so we know our period is pi, and if we're going from negative pi to 2 pi, that distance from negative pi to 2 pi is 3 pi. So we should see 3 full graphs between 0 and between negative pi and 2 pi. It is a Cos graph, so it starts up the top. So if we wanted to, we could start it at the top, which is negative 1. Every chunk it does something. So one chunk across, it goes to negative 2. Another chunk across, negative 3, our minimum. It goes up, goes back up to the center. Okay, so there's our first graph. We know that's a Cos graph from 0 to pi. Then we've got to do the same thing again. So it goes down, down, up, up. I think my dot was a bit wrong. Okay, now of course it goes back and follows the same pattern. So if we go back, down, down, up. Okay, from this we also know our endpoints. Negative pi, negative 1. That's going to be pi on 2. Negative pi on 2, negative 3. 0, negative 1. Pi on 2, negative 3. That will be pi and negative 1. This will be 3 pi on 2 and negative 3. And of course our n will be 2 pi, negative 1. I don't know why that graph didn't show up. Okay, so we see 3 full graphs. Our range, y is an element. Our lowest value we know is negative 3. Our highest value we know is negative 1. So that's our range. And our domain, of course, was given to us in the question. Okay. One more question with a different domain. So let's have a look. We've got sine 3x plus 1. For x as an element of negative 2 pi and 3 and 2 pi and 3. Now this one seems like it's awful, but it's actually not. We just got to follow, what did I do there? We just got to follow the chunk method. Okay, so let's write all of our information down. Our amp is 1. Our period, that's our nasty thing, that's 2 pi and 3, so it doesn't seem very nice. Our center is at 1. Our max is 1 plus our amplitude, which is 1, so it's 2. Our min is our center, 1 minus our amplitude, so minus 1, which is 0. So we know our range is from 0 to 2. Okay, our period is 2 pi on 3, so a chunk is 2 pi on 3 times 4, because we've got to divide it by 4. That's the same as multiplying the bottom by 4. They will cancel, and I end up with pi on 6. Okay, so each chunk is pi on 6. We've got to go from negative 2 pi on 3 to 2 pi on 3. So what I'm going to do here is say that's 2 pi on 3, and then that's negative 2 pi on 3. We know that our minimum is 0. We go to 1, and then we go to 2. Okay, now if you think about it, 2 pi on 3 is the same as, if we put it on 6, 4 pi on 6. So this 2 pi on 3 is the same as, if we cut it into 4, each one is going to be pi on 6, 2 pi on 6, 3 pi on 6, then that would be 4 pi on 6, which is 2 pi on 3. We can simplify this one as well. We can say pi on 3. And we know that it's symmetrical, so we can do the same thing to the negative side. So negative pi on 6, negative pi on 3, and we can change that one as well. That's pi on 2. 3 pi on 6 is pi on 2. And then here we've got negative pi on 2. Okay, so we know that we're going from negative 2 pi on 3 to 2 pi on 3. So the distance is 4 pi on 3, which means if the period's 2 pi on 3, we're going to fit in 2 graphs. Okay, it is a sine graph, so it starts in the middle. So we know it's a sine graph, it starts in the middle. And it's a positive sign, so it's got to go up first. It goes down, down, and then back up. Okay, it's going to be 2 pi on 3, 1. That's going to be pi on 6, 2. It's going to be pi on 2, 0. And we know our center's at pi on 3, 1. That's 0, 1. Now it'll follow back the same way. So it's got to go down, up, up, down. So it's going to go up, down, down, up. So we know these are all just a chunk or a quarter of a circle. So we know that's where each quarter occurs, but if for a chunk. So we know this endpoint is going to be negative 2 pi on 3, 1. Negative pi on 2, 2. Negative pi on 3, 1. Negative pi on 6, 0. So there we've pretty much done our full graph. We've got all of our turning points and our centers and our maximum and our minimum. And we know our range is y as an element of 0 to 2. Okay, so that's the basics of graphing sine and cos graphs. Next up, I'll show you how to graph tan graphs, and then also translations of sine, cos, and tan graphs. Hopefully this has been useful. I don't know whether you could hear my music playing in the background, but I assume some of you will laugh if you can. If you do, it's definitely not opera. Okay, have fun doing sine, cos, and not yet tan graphs, but you will soon. And yeah, make sure you understand how to do these for the next test or whatever you're doing at school. And if it's useful, don't forget to write a comment. Don't forget to like, share, and subscribe. And something about a bell. Notifications. Kids in class were telling me, turn on notifications. That's right. Okay, so that's basic trig graphs. This is the worm signing off from worms Maths Academy. Academy.